Now, last question, question D. So you have, oops. So you have this table of data, temperature in Celsius, Kelvin, and rate constant. You're supposed to use this table, determine the EA activation energy using graphical method compared to the value given in the equation in the question. So you're comparing this with this. Now, so in this case, what I've done, I kind of cheated. So in this case, I really just copied this table of values and plug it into an Excel spreadsheet. Now, I know this is the done product, so let me just hide a certain thing first, okay? Let me hide this, pretend you haven't seen any of this, and here, turn this into white. White. White, yep. So in this case, and cover this. Now, in this case, so that's the value, okay? Now, if you look at the graph, you have to remember what kind of graph you need to have. So you need to have on the x-axis 1 over t, okay? 1 over t. And on the y-axis is ln k. So in this case here, I go to my spreadsheet again. So this is a part where 1 over t. I did an equation 1 over this value and give me this, and I drag that. So all these are the 1 over t. And for k, ln k. Now, when I copied it over, it kind of have it like this. I haven't really quite figured out how to do this so that the Excel spreadsheet, I thought doing this will work. I wasn't able to. So in this case, I have to. So what ended up happening was I convert this by hand to the decimal numbers. And then I use the ln function here to have these numbers, okay? So that's where the ln k value comes in. Now, to graph the graph. Now, so to graph the graph, you need x-axis, y-axis, 1 over t, ln k. So in this case, I copy the value, just copy straight up the value there, and same thing as this. And I plot the graph. Now, when I plot the graph, I know it looks weird, and it looks like this. Okay, the axes are correct. I double checked it. So here, that's, you see, 0.0030. So yeah, these are their values. And so 1 over t is here. Ln, these are negative values, hence it goes down like this. So if you look at the trend line, now this is a very linear trend line. If you look at the trend line and look at the equation, I need to expand this a little bit better. Doesn't work. So when I expand this, you can see the gradient is minus 12274. So that's the gradient. So that's a gradient. Hello. So that's a gradient. Now, we're supposed to find EA. So EA, if you look at here, gradient equals minus EA over R. So, blah, blah, blah. So EA equals minus divided by over R, 8.31, which gives me this value. EA equals 1477. Now, I know the value looks weird. I double checked it. I even got Miss Aragona checked it, but it is. That's what she got too. So in this case, what we can say about EA, that's the EA of this reaction by the graphing method, and it is significantly bigger than the value here. And that would be the correct answer. So, I think that will be so that's the answer for question number D. You can look at it over here again. If you have any questions, come and see me. And yeah, I'll probably make a few more videos, but I'm not sure if I'll get it out tonight. Okay? Have a good night.